The instructor at Cold Water Boot Camp is Dr. Gordon Giesbrecht, professor of thermal physiology at the University of Manitoba, where he runs the lab for exercise and environmental medicine and studies human responses to exercise and work in extreme environments. Dr. Giesbrecht is one of the world's leading authorities on freezing to death and believes the best way to study cold on the human body is to get intimate with the elements. Gordon takes our boot campers into the classroom to teach them the 1-10-1 principle, 3 numbers that might help save your life in the event of a cold water immersion.
So we devised a way to remember all 3 phases and to remember this graph with what we call the 1-10-1 principle. And the first thing, of course, is do not panic, because you have 1 minute to get your breathing under control, you have 10 minutes of meaningful movement, and 1 hour before you become unconscious due to hypothermia. But the point is, you actually can survive a long time in cold water if you do the right thing. So the first effect we're going to talk about is the cold shock response. We tell people that it lasts about a minute. So the first thing that happens is gasping, and then hyperventilation. So you have the and then you have rapid breathing. Do not panic when you get in cold water. If you do panic, the psychological stress can actually feed the hyperventilation, so you just breathe uncontrollably, indefinitely. Normally, when we're walking, running, or swimming, we coordinate our swimming movements with our breathing. And if you can't control your breathing, you can't control your swimming, and then it just causes you to panic more because you're having more of a struggle, and it just becomes a vicious circle, and you have lots of problems. Keep your head above water as much as you can, because if you gasp when your head's underwater, you could inhale more than 1 liter of water in the first gasp, and if you do that, you're basically done. So don't panic. That breathing problem will pass. You have time then to consider your actions. So the second effect, cold incapacitation. It's all about just the effect of cold on muscle and nerve cells, right? Muscle cells do the action, nerve cells send the signal. You make either of those cold and you're not going to be able to perform. It's pretty, the physiology is complicated, but the principle is simple. Okay, so in water that's near freezing, incapacitation can occur within 2 to 10 minutes. That's going a little slower.
A little bit.
So the important thing about cold incapacitation is to know that once it kicks in and you start feeling weaker, it's only going to get worse. So what you want to do is have a plan of action, and after you survive that first minute, get those tasks done as soon as you can. So how can you minimize cold incapacitation? Obviously don't fall in the water. Get out of the water as quickly as you can if you are in there. If you can't, then you want to get as much of your body out of the water as possible, like holding on to an overturned boat or sitting in an upright boat that even if it's underwater, it can still keep much of your body out of the water if you're sitting on there. So regarding cold incapacitation, consider the following points. The first one is you have 10 or maybe 20 minutes of meaningful movement, and then you'll start getting weaker. And once that happens, you need to prepare for the eventuality that you will not be able to do anything for yourself. Now, if you survive the immediate short-term and mid-term phases, cold shock response, cold incapacitation, and you've not been rescued, but you're able to keep your head above water, you have a life jacket on, then you'll enter the third phase, which is hypothermia. And again, we said that takes at least 30 minutes to maybe an hour, even in cold, ice cold water. So just how cold is cold? We call cold water anything below 20 degrees Celsius, because anything below that, most humans, if they're in that water long enough, will eventually become hypothermic. They can't defend against those temperatures indefinitely. There's a number of things that can affect the core cooling rate. Obviously the water temperature, the colder it is, the faster you get cold. the amount of the body that's immersed. That's why we tell people get as much of your body out of the water as possible. Body morphology, that's a fancy word for basically how much fat do you have and how much do you weigh. And generally, folks who weigh more will cool slower. So if self-rescue is not possible, there are some actions that you can do to minimize heat loss, and you've probably all heard of the HELP response, heat escape lessening position, where you put your arms into your sides and put your legs together and crouch a bit. And of course, you can only do this if you have a life jacket on. And also there's the huddle position, where 2 or 3 people can actually form a huddle, and by pressing themselves together, they can decrease the surface area for heat loss to the water. Metabolic heat production, if you are shivering, that is really producing heat, people who shiver more will produce more heat, and that'll slow down your descent into hypothermia. So regarding hypothermia, consider these following points. You want to delay the onset of hypothermia as much as possible. The HELP position, huddle position, exit the water as soon as possible, and if it's not possible, get as much of your body out of the water. So in closing, let's just review the 1-10-1 principle, which actually encompasses all 3 phases of what happens to you in cold water. The first thing is you have 1 minute to get your breathing under control. Don't panic. That breathing problem will pass. You have time then to consider your actions. You have 10 minutes of meaningful movement for self-rescue or to prepare to wait to be rescued if you couldn't self-rescue and you're starting to get weaker. And you have 1 hour before you become unconscious due to hypothermia. And remember that if you can keep your airway above the water, you won't die because you're unconscious. So you might survive another hour or more if you have a life jacket on, and you can keep your airway open until your heart cooled enough to actually stop working.